Hi everybody, my name is Albert Theuwissen and I'm happy to introduce to you the online course about the evaluation, characterization of noise in a CMOS camera. First question that you can ask is why this training? Well, noise plays a very important role in the definition of the subjective as well as in the definition of the objective quality of an image. Noise also is a very important parameter when it comes down to the definition of signal-to-noise ratio, as well as to the definition of the dynamic range. Noise is determining also the lowest light level that one can use when capturing images with a solid-state camera. And actually, noise was always and is still always too high. So in conclusion, you can say that basically the noise is a very, very important parameter to determine the performance of an image sensor and to determine the performance of a camera. And actually, what can be measured can be improved. So how will this training be run then? Well, what we are going to do is that we are going to characterize the noise very simply by acquiring raw images, raw data by means of our device under test. And what we will do is we will capture images in dark and later on we will capture images with light. The raw data of the images will be statistically analyzed, that's the next step. And as you will see, there's absolutely no need for any fancy hardware or any expensive software that we need to analyze or to measure the noise. Besides the camera under test, the only thing that we need is a computer. There is no need to perform any absolute measurements, and actually there is no need to know what's inside the camera or actually what is inside the sensor. What are we going to measure in this training? Well, for the full set of measurements, that basically means characterization of noise in dark, characterization of noise with light, the following noise parameters can be retrieved. We are going to find the fixed pattern noise in dark and in light. We are going to find the temporal noise in dark as well as in light. And next, for all these types of noises, we are going to split up the contribution of the row, the column and the pixel. And actually that's not everything, because besides the noise parameters, also other parameters can be retrieved from the same data with the same operations, such as the dark current, the conversion gain, the full well capacity or the saturation level, the maximum signal-to-noise ratio that we can get out of the sensor, and finally, the dynamic range. An important remark I would like to make over here is that all our noise parameters will be expressed in electrons. Our dark current measurements, they will be expressed in electrons per second. It's of vital importance that if you would like to compare devices or if you would like to compare technologies with each other, you have to do this in the charge domain, expressing the parameters in electrons. If you work in the voltage domain or if you work in the digital domain, then actually you always include the conversion gain. And in that case, the comparison between technologies and cameras or between sensors can actually be very unreliable. I show you a list of parameters, I show you a list of numbers over here that we could retrieve during the training. You see that the total fixed pattern noise is relatively high, very close to 30 electrons. You see that the total temporal noise is pretty high as well, 25 electrons. And you may ask yourself, is this measurement method only working for large values of noise? Actually, the answer is no. As a comparison, I showed you also the results that we obtained by using a modern device, a low noise device that is available on the market these days. And in this particular case, you see that the total fixed pattern noise is an order of magnitude less. Also, the total temporal noise is much less than in the device that we are testing. I would like to focus especially on the extremely low noise levels that we found for the raw FPN, around 0.15 electrons, by means of the simple measurement method that is explained in the training. Is this really a hands-on training? Well, actually, the answer is yes. We made available to you all the images that are being used during the training. So you can download all the images in dark and you can download all the images that were taken with light. And after downloading, you apply very simply the statistical evaluation methods that will be explained in the training. And for these mathematical operations, you can use any available tool such as MathCAD, MATLAB, Python, you name it. Finally, you can compare the results that you obtained with the data that is given in the training. So what are the benefits of this training? Well, besides the details about the measurement method, extensive information will be given about the theory that is behind this methodology. Also, extensive information will be given about the obtained results. The complete training contains over 250 sheets with data, with graphs, and with images. You learn how to characterize these noise parameters, fixed pattern noise as well as temporal noise, by means of a very simple evaluation method. No absolute measurements, no knowledge about the image sensor or about the cameras are necessary. You learn how to find the noise contributions of the rows, of the columns as well as of the pixels. And this gives very important information about the location of the dominant noise source. Also, beside the characterization of the noise, you will learn how to quantify other important parameters that you can retrieve by means of the same methodology. Examples are saturation level, dynamic range, dark current, and maximum signal-to-noise ratio. Extensive explanation will also be given in the training about the famous photon transfer curve as well as the mean variance method. Advantages of both methods, but also limitations of the two methods will be explained. And last but not least, you will learn about the relationship between the various performance parameters and about the pitfalls that can show up in data sheets as well as in advertising material. I do hope that I give you enough information about the training, about the content, about the whys and the hows and the benefit of the training. And I do hope to see you back during the training. Thank you very much. Bye-bye.